All right, so we're going to look at tangent and normal, but first we need to make a correction. We had what? 1 over 2 when x is 2. So this is when x is equal to 2. We had 1 over 2, and what it should have been is 1 over 4 minus 1 over 2 minus 1, which is 1 over 1, which is 1. So it's minus 1. And a quarter minus 1 would be equal to minus 3/4. So this is the gradient of the curve when x is equal to 2, and the gradient of the curve is equal to the gradient of the tangent. To get the gradient of the normal, I must invert the gradient of the tangent and change its sign. So the gradient of the normal, invert 3 over 4, I would get 4 over 3, and I would change the sign from negative to positive. The answer is positive 4 over 3. So let's go to equations of tangent and normal. All right, from CSEC, I normally use this as sort of like a formula for calculating, for determining the area, for determining the equation of a straight line. My formula is y is equal to m into x minus x naught plus y naught. So this is the formula for the equation of a straight line. M is the gradient and x naught, y naught is the coordinate of any point on the line. So as with any formula, every formula must have an input. The area of a circle is pi r squared, and the inputs for that is pi and radius. So the inputs for this formula are the gradient and the coordinate of any point on the line. So the inputs are m and x naught, y naught. M is the gradient and x naught, y naught is the coordinate of any point on the line. So again, my formula for determining the equation of a straight line is y is equal to m into x minus x naught plus y naught. And the inputs for this formula are m, which is the gradient, and x naught, y naught, which is the coordinate of any point on the line. All right, let's have a look at an example. All right, I will do example 27, you will do 28. This says find the equation of the tangent to the curve y is equal to x raised to the cos x power at the point where x is equal to pi by 2. All right, first of all, I'm basically doing a differentiation of this form. The form y is equal to a to the power x. What I'm doing is a differentiation of that form. All right, so let's do it. So we have y is equal to x to the cos x power. All right, and I'm being asked to find the equation of the tangent. So the first thing I'm going to do is I'm going to find dy by dx, which gives me the gradient of the curve. But the gradient of the curve is equal to the gradient of the tangent. So by knowing the gradient of the curve, I automatically know the gradient of the tangent. So to differentiate a function of this form, I would first find ln for both sides. So I have ln y is equal to cosine x ln x. So what I just did there is I did a reverse application of this law of indices. The log of a to the power b is equal to b, the log of a. Now the reverse application, it's an application of that law of indices. All I did, or law of logarithm, all I did was I found ln for both sides. And then now, once I find ln for both sides, the power, which is cos x, can come to the front. So now I'm ready to differentiate. If I differentiate ln y with respect to y, that's sort of like an implicit differentiation. If I differentiate ln y, I'm going to get 1 over y. Then I have to multiply by the differential of the inside function, which is y. When I differentiate y, I'm going to get dy by dx. That's the left-hand side. On the right, I have a product where I'm multiplying two functions in x. So I'm going to apply the product rule, which is to leave the first, cos x, differentiate the second, ln x, you get 1 over x, plus differentiate the first. When I differentiate cos x, I'm going to get minus sine x. Leave the second, I get what? ln x. So dy by dx, 1 over y, dy by dx would be equal to cos x over x minus sine x ln x. I'm going to bring the y to here. Or if I want, I could say I multiply both sides by y. I'm going to multiply both sides by y, and I'm going to get dy by dx is equal to y into the cosine of x divided by x minus the sine of x ln x. All right. But y is equal to x cos x. So I'm going to say dy by dx is equal to x, the cosine of x, into the cosine of x divided by x minus the sine of x ln x. So now that we differentiate, I can say when x is equal to pi by 2. So when x is equal to pi by 2, dy by dx, which is the gradient of the curve, would be equal to pi by 2 raised to the cosine, raised to the cosine of the pi by 2 power. So that is dy by dx is equal to pi by 2, which is x. And this is to the power, the cosine of pi by 2 into the cosine of pi by 2 over pi by 2 minus the sine of pi by 2 times ln pi by 2. So this is when x is pi by 2. I think the cosine of pi by 2 is 0. The cosine of 90 is 0. So this is 0. This is 0. The sine of 90 is 1. So this is 1. So what I have is pi by 2 raised to the 0 power. Sorry, I should have put this in bracket. Pi by 2 raised to the 0 power into 0 over pi by 2, 0 over pi by 2, which is still 0, minus 1 times ln pi by 2. Anything raised to the 0 power is 1. So this is 1 into 0 minus ln pi by 2. So the gradient when x is equal to pi by 2 is minus ln pi by 2. All right. So what were we asked again? We're asked to find the equation of the tangent. So right now we have the gradient. Remember, for you to determine the equation of a straight line, because the tangent is a straight line, there are two things you need. You need the gradient of the tangent and you need the coordinate of 1 point on the tangent. So 1 point on the tangent is the point of contact. So what I'm going to do is I'm going to say y would be equal to, we have the value of x already. X is pi by 2. So when x is pi by 2, what would y be equal to? Y would be equal to pi by 2 raised to the power the cosine of pi by 2. The cosine of pi by 2 is 0, and anything raised to the 0 power is equal to 1. So this is 1. So the x coordinate is pi by 2. The y coordinate is 1. This is the coordinate of the point of contact. The point of contact is where the tangent touches the curve. So how did I find that? We already say when x is equal to pi by 2, and we found the gradient, which is minus pi over 2. Then I said again, when x is pi by 2, I then find the value of y. When I have an x coordinate and I have a y coordinate, what I have is the coordinate of a point. This point is the point of contact. It is where the tangent touches the curve. Now, where the tangent touches the curve is 1 point on the tangent. Now, using the formula, y is equal to m into x minus x naught plus y naught, where this is my x naught, this is my x naught.
Wait, excuse me, sir.
Y naught. Give me 1 second, please. And m, the gradient is, let me finish and then we can deal with the questions. M is ln pi by 2. Unless it is here telling me I made a mistake. Are you telling me I made a mistake?
No, sir. I was asking about what did you say about the y equal pi by 2 cos pi by 2 equal 1? How did
That is
we
the value of
that?
y when x is pi by 2.
Okay, so you just put in pi by 2 in the equation. No problem,
Replace
sir.
x. This is y. This is the function you were given. Y is equal to x raised to the cosine x power. So when x is pi by 2, I take out the x. Wherever I see x, I take it out and put pi by 2. So that gives me the y coordinate. So let's put in the values now into the formula. M is minus ln pi by 2. X minus x naught, which is pi by 2, plus y naught, which is 1. This is technically the answer, but let's get it in the form y is equal to mx plus c. I'm going to remove the bracket by applying distributive law. So this is minus ln pi by 2 x minus, sorry, negative times a negative is a positive, positive pi by 2 ln pi by 2 plus 1. So the equation of the tangent is y is equal to minus x ln pi by 2 plus pi by 2 ln pi by 2 plus 1. That's the final answer. I'm going to stop this video. Then you can ask me any question you want about what I just did.